Okay, in this module, we're going to talk about algorithms. So if you're interested in programming, you might have heard the word algorithm come up. You might have heard algorithms and data structures as sort of this core part of programming. So let's talk about what an algorithm actually is. Well, in the earlier modules, I was talking about the rule sets that you would have to write as a programmer for a computer to actually execute. And then we talked about the problem solving that has to go into that to be able to actually think about the problem and the solution and then codify it. But that's really just creating an algorithm. An algorithm is the set of rules that a computer is going to have to go follow based on the inputs and outputs that you've defined for it. It's truly nothing more than that. So you might have heard about popular algorithms that are complex. There was mathematical proofs to actually come up with them. And yes, those are absolutely algorithms. Yes, they can be codified and programmed, but that doesn't mean that every algorithm that we talk about as programmers has to be something as complex as having a mathematical proof to go along with it. And we mentioned this in an earlier module, but you don't have to be a math whiz to be able to be a programmer. And I think a lot of the time, for people with a formal education in programming, or for people that have heard about these other individuals getting a formal education, hearing about algorithms, hearing about all these mathematical proofs and stuff that go into them, I think that that can be a real deterrent for people that are like, look, I'm interested in programming, but math is just not my strong suit. And that's totally okay. I've been programming for 20 years, and I can say that I've written hundreds of algorithms, and there's not a single time where I've done a mathematical proof to actually illustrate and prove to myself that my algorithm works properly. Now, maybe there's a computer scientist out there that heard me say that, and they're thinking, how could you not have mathematical proofs for your algorithms? But the reality is, when we're developing software for the real world, you're not going to be writing mathematical proofs for a lot of the work that you're doing. It just isn't applicable. So don't let the word algorithm scare you. An algorithm is really just the set of rules that you're putting together that's going to create your program. So let's come up with a simple algorithm for something that we might do every day. In fact, I'm going to make this one up on the spot. Let's look at the lights that are behind me, right? So if I said I need an algorithm to be able to turn on the lights, what might that look like? So maybe the first part of the algorithm is, are the lights on or not? If the lights are already on, well, we can finish. We're already done. We've accomplished the goal of having the lights turned on. That's really the most simple case that we can encounter. Kind of feels like cheating, so let's think a little bit further. Okay, so the lights are off. What's the next step that we have to do to be able to turn the lights on? Well, these particular lights are actually controlled by a remote. So if the lights are off, step one after that might be find the remote. The step that follows that is, if we found the remote, what button do we need to press to turn the lights on? And let's assume this remote's very simple. It just has an on and an off button. So if we found the remote, the next step would be press the on button. And at that point, the following step might be, are the lights on or not? Because if the lights are on after we press the on button on the remote, we're totally done. And at this point, we've kind of created the basic part of an algorithm for turning the lights on. But if you think about the different edge cases that might happen, if you think about this a little bit harder, you might be able to add in some other different variations to this algorithm that handle those. So for example, if the lights didn't turn on when you pressed the on button on the remote, what might you do? Maybe you might say, well, we have to aim the remote at the lights. It's a detail that you might not know about these lights. Or what if I said, well, maybe the battery's dead in the remote. So part of your algorithm might be, check battery or something like that. But again, if you're thinking about what I'm saying and not the very specifics, just the generalization, the idea is that we're literally just creating a set of rules to go follow to accomplish a goal. And these rules that we're creating are really the algorithm. And the part that follows is that, like we talked about in the earlier module, you're taking the algorithm that doesn't have to be in a programming language, right? I just verbalized an algorithm to you, but you would take that algorithm and then you translate it into a programming language. And then, like we talked about in the other earlier modules, is that there are tools like interpreters and compilers that take that programming language and actually convert that into something that the computer can understand and execute. So that's algorithms in a nutshell. It's just the set of rules that a computer needs to follow to execute your code. And no, you don't have to be a math whiz to be able to write algorithms. That's it for this module. Let's move on to the next one.